Alright, so let's dive into the discussion of actual CPU scheduling algorithms now. The simplest CPU scheduling algorithm that we'll talk about is the first come first serve scheduling. As the name implies, in the FCFS or first come first serve scheduling algorithm, the processes are picked for execution in the order of their arrival in the ready queue. The processes that request the CPU first, they are allocated the CPU first. The implementation of FCFS scheduling is pretty straightforward. The implementation essentially needs a first in first out queue. So let's assume this is the state of processes in the system. Process P2 arrives first and therefore it is at the head of the queue, followed by process P1 and followed by process P3. So this is our ready queue in first FCFS scheduling. So the way this will work is, let's say a new process P4 now enters the system. So the PCB or the process control block of this new process would be linked to the tail of this queue. And when the CPU is free, it would be allocated to the process that is at the head of this first come first served queue. Let's walk through this example to better understand the FCFS scheduling. Let's assume we have these three processes P1, P2 and P3 entering our ready queue. Let's assume that P1 requires 24 milliseconds to execute, P2 and P3 they both require 3 milliseconds to execute, and this is the order in which they entered the ready queue, right? So basically P1 entered first, followed by P2, followed by P3. This bar chart over here, this illustrates the schedule, the CPU schedule that would be generated by the FCFS algorithm for these processes in this example. In operating systems, this bar chart is actually known as a Gantt chart. So remember this term, Gantt chart. So P1 came in first. According to the FCFS scheduling algorithm, we will allow this P1 to execute first on the CPU. So let's assume that the execution starts at time 0. Because P1 requires 24 milliseconds to run, P1 would finish at 0 plus 24, basically 24 milliseconds. When P1 finishes, now we need to figure out which process should go next. So note that in FCFS will schedule processes in their arrival order, right? So next P2 had arrived. P2 arrived second, followed by P3. So we'll now pick P2 for execution on the CPU. So P2 will start at time 24, and because P2 requires 3 milliseconds, it would run until 24 plus 3, 27 milliseconds or 27 time units. And finally, when this P2 terminates at 27 time units, we'll let the last process P3 execute, and P3 will finish at 20 because it starts at 27 and requires 3 milliseconds. It will finish as 27 plus 3, 30 milliseconds. So this is how the schedule for this FCFS algorithm is computed. Now let's evaluate this schedule using the average waiting time for each of these processes. So note that all of these processes P1, P2 and P3, we are assuming that they all entered the system simultaneously here at time 0. So the start time for each of these processes is 0. Now P1 was scheduled immediately after entry at time 0. So P1 did not have to wait at all, right? So the wait time for P1 was 0. Now P1 finished at time 24, and after that P2 was scheduled, but P2 was waiting. It had arrived at time 0, but it got to run after P1 finished at time 24, right? So the wait time for P2 was 24 minus 0, which is 24 milliseconds. Similarly, P3, it entered the system at time 0, but it started execution here at time 27 after P2 ended, right? So the wait time for P3 is 27 minus 0, which is again 27 units. So the average waiting time for all the three processes is P1 waited 0 milliseconds, P2 waited 24 milliseconds, and P3 waited 27 milliseconds. So the average is 0 plus 24 plus 27 divided by 3, which is basically 51 divided by 3, which is 17 milliseconds. The solution is also summarized over here.